All right, so here's the last of the Newton's laws of motion in terms of the more conceptual area. The reason why we do this one last is because this leads into the mathematics of Newton's laws, okay? So one thing to note is recall that Newton's first law, right, of motion explains what happens to an object that has no net force, okay? So that's when if you want to say the sum of the forces, which is what our net force is going to equal 0. Okay. Now, Newton's second law of motion answers the question of what happens to an object that does have a net force acting on it. Okay. So what happens when those forces are no longer balanced and they're unbalanced, right? So that's what Newton's second law is going to look at, is the unbalanced forces. Okay. Okay, so what this law really does is that it just simply redefines acceleration. And so that's what's happening. When we talk about kinematics, we talk about duck-on-pound physics, right? We didn't care about what was happening below. Now this Newton's second law that focuses on the below the water, okay? So it states that the acceleration is directly proportional to the net force that is acting on an object, okay? And inversely proportional to the mass of the object. Right? So you're going to see, math terms here. He defined a lot of stuff using math. So first thing we're going to note is that the acceleration is directly proportional to the net force, right? But then it's inversely proportional to the mass of the object. Okay? So, and basically what happens is, and we'll get into it here in a second what what this breaks down to be, but remember, the net force, right, when we say anything with net means we sum it up, okay, so the net force is the sum of all the forces that are acting on the object, and it can be acting in the horizontal or vertical directions, okay? So this isn't just a phenomenon that affects the horizontal motion or the vertical motion, it affects both motion, okay? Another way to think about this law is that it's his mathematical law. It's his mathematical law of motion. He has other laws that are mathematical based, but when we talk about Newton's law of motion, this is this is his mathematical law. Okay, so by his definition, okay, the formula is A equals F divided by M. Okay, in fact, this is the sum of F divided by M. Okay, but how do we know this formula most commonly? So we just say the net force. Oops, sorry, put the symbol in the wrong spot. Oh, hand. I want to erase. Okay, I'm going to erase that. Okay, so we're saying that the sum of the forces is equal to the mass of the object times the acceleration. Okay, so what happens is, if, let's say, the acceleration increases, the force will increase. Okay, if the mass increases, right, and these are those more conceptual-based questions that you can see in multiple choice questions. So if the mass increases, right, the force will increase. And then these two, the acceleration and the mass, right, they have an inverse relationship. So if mass increases, acceleration decreases. Okay, keeping that. So the black arrows is if I keep the force the same. The green arrows mean if I kept the acceleration the same. The red arrows meaning if I kept the mass the same. Okay. So one thing to note is that Newton's first law is just simply a special case where acceleration is equal to 0. Okay. When we talk about the sum of the forces, that are acting, it's just simply, a special case, right? And when it's all balanced, this is 0. So 0 meters per second if balanced, right? Because it's not accelerating. All right. So again, just some reminders. The SI unit for force is the Newton. Okay. And that's one of the reasons why we don't use N for normal force, because the unit is N. Okay. So again, Remember that this is not mass, right? When we talk about weight and force, well, it's not mass, okay? And so the U.S. customary unit for force is actually pounds, right? So when you go to the doctor, they tell you how much you weigh. Well, they're telling you how much force you're experiencing due to gravity. Okay? And the conversion factor is 1 Newton is equal to 4.45 pounds. Okay? And so that's the conceptual basis for Newton's second law. In the next bunch of videos, we're going to look at specific examples dealing with the mathematical process in solving these problems.